Hello students, in this video we are going to see the problem on motion curves. Now see, the question is given here as a VS graph is given in figure A below. Find the velocity and acceleration at s equal to 50 meter and s equal to 150 meter. Means two displacement values are given here, and for each displacement value we have to calculate velocity and acceleration. So see, this figure is given also in question, in which on y-axis there is velocity given in meter per second and represented by v, and this horizontal x-axis displacement is given in meter and represented by s. So this triangle we can see in this figure, in which the crest or the maximum value of this triangle is given, that is 8 meter per second. Means the maximum attainable velocity is 8 meter per second. So 0 to 8 is the acceleration, and 8 to again 0, that is the retardation. Let's go to solution of this problem. From property of similarity of triangle shown in figure B. Now see here, in this figure this triangle is divided into two parts. So first of all we have plot here the displacement 50 and 150 on the displacement line or on the horizontal x-axis. So when we draw vertical line through this 50 and through this 150, so these lines meet to the triangle sides 0 to 8 and 8 to 0 at the midpoints, and this midpoint velocity is given, that is 4 meter per second. This is also a 4 meter per second. So this side considered as the acceleration, because here 0 to 8 the velocity is continuously increasing. Now see, as well as the displacement, you can see from 0 to 8 both velocity and displacement are increases, but from 8 to 0 at the right side the velocity decreases but the displacement increases. So this side is the retardation side. So at s equal to 50 meter and s equal to 150 meter, the value of v or the velocity is 4 meter per second. Just we have seen here for displacement 50 meter and for displacement 150 meter, the velocity here is the same, that is 4 meter per second. Then we know that a equal to v into dv upon ds. V into change in velocity upon change in displacement is equal to acceleration. And the slope of this figure, the slope we know that how to find out the slope. So to find out the slope, so we use y2 minus y1, means vertical distance. Here the vertical distance, this is y2 value and this is y1 value. So this is y2 minus y1 upon x2 minus x1. So this is x2 value and this is x1 value. So by using this we can find out here the slope. So the slope is given here, change in velocity upon change in displacement. So now see, at s equal to 50 meter, the slope is given, that is dv upon ds 4 upon 50. So this considered as y2 value and this is y1 value. Y1 is 0 and y2 is here 4 meter per second. So y2 minus y1 means 4 minus 0 equal to 4. So this is taken as 4 here, and ds means x2 minus x1. So here the x2 value is considered as 50 meter and x1 is considered as 0. So therefore 50 minus 0, so equal to 50. So in this way we got here the slope dv upon ds equal to 4 upon 50 for the displacement s equal to 50 meter. So now when we will go to find out the acceleration, so we have to use this formula which is written here. So a equal to v into dv upon ds, so equal to 4 is the velocity, so velocity is the common for both the displacement, so therefore we have taken here 4 into dv upon ds, just we have find out here the slope as 4 upon 50. So this is 4 upon 50 written. After solving this, we get a equal to 0.32 meter per second square. So this acceleration we got at s equal to 50 meter. Now we are going to find out the acceleration when the displacement s equal to 150 meter. So for this, the slope is given dv upon ds. So just I told you 0 to 8 is the acceleration and 8 to 0 this is the retardation. So for acceleration we considered here the positive value, and here for the retardation we considered as a negative value. So now see dv upon ds equal to minus 4 upon 50. Then the same formula we have to use here to find out the acceleration. So a equal to v into dv upon ds. Here the value of v is 4 meter per second into dv upon ds means slope just we have calculated here is taken minus 4 upon 50. After solving this we get here a equal to minus 0.32 meter per second square. So in this way we have calculated here the value of acceleration for s equal to 50 meter and for s equal to 150 meter. For s equal to 50 meter we got acceleration a equal to 0.32 meter per second square, and for s equal to 150 meter we got acceleration a equal to minus 0.32 meter per second square. Thank you for watching this video.